Efficient, eco-friendly, sustainable Mediterranean greenhouse integrated with artificial intelligence, high-tech automation and control system. SusMedHouse project. The aim of SusMedHouse project is to develop technologies, software and methodologies for a sustainable greenhouse system to enhance the productivity and decrease the consumption of resources through artificial intelligence with innovative greenhouse applications. All developments will be demonstrated in the SusMedHouse demonstration greenhouse to be built in the scope of the project. To understand the growers' needs and common greenhouse crop requirements, interviews have been carried out with greenhouse owners, technicians and agricultural engineers, and to understand the current technological status in the Mediterranean greenhouses, literature review and site survey studies have been performed. Knowledge gathered during literature review, interviews and site survey studies provided input for the technical work packages of the SusMedHouse project to produce the most efficient, eco-friendly, sustainable and socially accepted solutions for Mediterranean growers. With respect to the artificial intelligence, AI, and decision support system (DSS) development, more than 250,000 labeled images dataset, including visual and numerical datasets for tomato, pepper, and lettuce, have been created and used in deep learning and optimization studies. Till the end of the project, 500,000 labeled image dataset will be created. The image processing and AI software is composed of several machine and deep learning algorithms, achieving promising results on detecting anomalies, monitoring and tracking pest population inside the greenhouse, and providing necessary information for decision support system's harvest prediction function. A robot has been developed for taking photos of the crops in the greenhouse to be analyzed by the developed image processing and AI software, and will also be capable of efficiently spraying the crops when anomalies are detected by the software. To create the best user experience, the information gathered by the cooperation of the robot and AI software is made available to the users through a decision support system with a user-friendly interface. Decision Support System is developed as a desktop application, and development of web-based application is ongoing. Features of Decision Support System include smart management of greenhouse, monitoring crop and greenhouse conditions, harvest prediction, and early warning system. Decision Support System acts as a bridge between growers and high-tech solutions of SusMedHouse to ease the management of the greenhouse and to improve efficiency and sustainability. To find the best environmental conditions and fertigation composition for tomato, lettuce and pepper plants that's going to complement the high-tech solutions of SusMedHouse, particle swarm optimization algorithm has been tailored for plant cultivation and optimization software was developed in Python programming language. To perform the optimization experiments in a timely manner, plant cultivation cabins have been built in the backyard of Artex. A control and automation system was developed to precisely control the environmental conditions and plant irrigation in the cabinets. Through these experiments in cabinets, an artificial lighting system designed for optimum growth of lettuce, tomato and pepper plants used respectively. These experiments have been completed and best environmental conditions and fertigation composition for tomato, lettuce and pepper plants have been found for different stages of the crops and will be used in the SusMedHouse demonstration greenhouse. To achieve the most efficient and eco-friendly greenhouse cultivation, an important step has been taken that maximizes sustainability by optimizing the plant growth while minimizing the consumption of resources. Disruptive biosensor technology of SusMedHouse enables real-time, reliable and on-site analysis of water quality regarding biochemical, biological and microbiological parameters and toxicity information automatically with drastically lower cost compared to current technologies. Moreover, this technology allows online monitoring and can provide real-time feedback and early warnings with artificial intelligence. Currently, novel biochemical oxygen demand and toxicity biosensors have been developed, and development of microorganism quantification biosensor, integration of biosensors, multi-parameter and control software will be completed next month and will provide the automated system for integrated biosensors, ASIB, to work properly, to manipulate and adjust easily, and to allow reliable and repetitive analysis over time. To improve the energy efficiency of the greenhouse, sunlight and lighting optimization by the development of the solar control coatings and agro-photovoltaic panels have been completed for the SusMedHouse demonstration greenhouse, also regarding its location. The idea was to develop functional coatings for the plastic cover of the greenhouses that either decreases the energy loss of the greenhouse during wintertime in cold regions, or that limits the heat intake into the greenhouse in summer by cutting off the near-infrared portion of the solar radiation. The coatings were deposited by sputter deposition and tested in climate chamber and condensation tests and sent to Ankara to be integrated in the SusMedHouse demonstration greenhouse. The daylight simulations were conducted to analyze the shading ratios in the SusMedHouse for different photovoltaic integration scenarios. The sunlight requirements of the crops were prioritized for analyzing the light availability and homogeneity in the greenhouse. The idea was to utilize PV panels to reduce excessive heat and irradiation that are harmful for the plants and generate clean energy. Final design has been completed to be implemented in the SusMedHouse demonstration greenhouse. The lab-scale production and study of 5 high-quality composts were carried out using a selection of organic waste, including tomato and pepper plant residues. By mixing the most promising compost with a selection of suitable zeolites, up to 8 innovative peat-free growing media that are zeocomposts were designed, analyzed, and verified in preliminary agronomic tests. The best-performing zeocompost is currently in production in an on-farm composting plant at Eboli located in Salerno, Italy, and will be shipped to Turkey for testing and demonstration at SusMedHouse demonstration greenhouse. New eco-friendly methods to fight pests and pathogens are continuing to be developed that also includes improving spraying quality that's a major challenge to growers. Sustainability will be evaluated from social, environmental, and economic aspects. Moreover, business models and market analysis will be evaluated to understand the project's idea, economic success, and market fitness in the second half of the project. A 2,000 square meters greenhouse is currently under construction in Ankara, Turkey, to be finished till the end of 2021. This greenhouse will have 4 different sections representing agrophotovoltaic, aquaponic, hydroponic, and conventional greenhouses. The subsystems developed by partners will be integrated to the greenhouse once it's completed. Operational tests and accordingly improvement and modifications will be done throughout the demonstrations. Project website incorporating an intranet as a project repository and a risk analysis tool has been created and updated. Moreover, social media accounts on LinkedIn, Facebook, and Twitter have been created and project news are being posted systematically. A poster, a flyer, and 3 newsletters that are downloadable from the website have been produced. Furthermore, a video for the project has been created, and the workshop on business planning and modeling have been organized with all partners. After a long delay to organize a face-to-face meeting due to COVID-19 pandemic situation, finally, the first face-to-face meeting has been held in Antalya, Turkey, with the participation of all partners at the end of November 2021. During the meeting, the current status of the SusMedHouse project, progress and possible risks have been discussed, and future planning has been made. Moreover, GrowTech 2021 International Agricultural Fair and Antalya Tarım greenhouses and facilities have been visited with the participation of all partners. During the meeting, it was evaluated that planned tasks, other than the submission of 2 deliverables for the 18 months period, were carried out by compensating COVID-relevant delays by all partners, and also, it was agreed on that all partners will do their best to complete the SusMedHouse as promised in the proposal by the end of February 2023.